All right, this is section 5-6, inequalities in one triangle. All right, let's start off with some vocabulary. So circle the labeled exterior angle. So right here is my exterior angle. So that means the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Now let's draw an exterior angle adjacent to angle 1 and label it angle 5. So here we go, and there's angle 5. All right, circle the statement. Oh, that's 1, so that works there. We could have also drawn that one, couldn't we have? All right, so circle the statement that represents an inequality in each pair below. So an inequality, x is not equal 32. The number of votes is greater than 10,000. Okay. Y is less than or equal to z would be y is less than or equal to z. The temperature is at least 80 degrees would be T is greater than or equal to 80 degrees. So to compare means to examine two or more items, noting similarities and differences. We're going to use inequalities to compare amounts. So by comparison, a spider has more legs than a beetle. You can compare products before deciding which to buy. To compare quantities, you can write an equation or an inequality. All right, property, comparison property of inequality. If I know A equals B plus C and I know C is greater than 0, then A must be greater than B. So circle the group of values that satisfies this comparison property of inequality. Well, this satisfies that. You can try it out. So to go along with this, a corollary to the triangle exterior angle theorem, the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior. So if this equals the sum of those, this must be greater than the individual ones. So circle the angles whose measures are always less than the measure of angle 1, 3, and 2. Okay, let's apply that. So in the figure at the right, y is measure of angle 5 greater than the measure of angle C. Justify. So measure of angle 5, or angle 5 is an exterior angle of triangle ADC. How do I know that? Definition of an exterior angle. How do I know measure of angle 5 is greater than measure of angle C? By the corollary to the triangle exterior angle theorem. Okay. So we can use the corollary to the triangle exterior angle to prove the following theorem. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So if xy is greater than if xz is greater than xy, then we know the measure of angle y is greater than the measure of angle z. Theorem 511 is related to theorem 510. Write the text of 511 by exchanging the word larger angle to larger side. So if two sides of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay. So let's use this. In the figure to the right, we know measure of angle S is 24, so I like to mark that. And measure of angle O is 130. Which side SOX is the shortest side? All right, so by using the triangle sum theorem, I know that measure of angle X must be 180 degrees minus S minus O. So plugging in the measurements, 180 degrees minus 24 minus 130, and I get 26. All right, so let's fill in the angles. Measure of angle O is 130. Measure of angle X is 26, and the measure of angle S is 24. So the opposite side for 130 is SX. Opposite side of X is SO, and opposite side of S is OX. All right, so what is the shortest side? The shortest side has to be OX because it is opposite the smallest angle S. All right, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So xy plus yz equals x is greater than xz. Yz plus yx is greater than yx. yz plus yx is greater than yx. I'm saying this wrong. Yz plus zx is greater than yx. Yx plus xy is greater than zy. Okay. So let's use that. Can a triangle have side lengths 2, 6, and 9? So the sum of any two sides must be greater than the third. Okay. So 2 plus 6 equals 8. Is 8 less than 9? Okay, 6 plus 9 equals 15. 15 is greater than 2. 2 plus 9 equals 11. 11 is greater than 6. So one of the sums is not greater than the length of the third side. So it is not possible for this triangle to have lengths 2, 6, and 9. So a triangle has side lengths of 4 inches, 7 inches. What are the range of possible lengths for the third side? So we set up an inequality. So x plus 4 must be greater than 7. Subtracting 4, x must be greater than 3. But also, x plus 7 has to be greater than 4. So subtracting 7, x has to be greater than negative 3. 7 plus 4 has to also be greater than x, so x has to be less than 11. The length is always positive, so the second inequality pair is invalid in this situation. So write the remaining inequalities. X must be greater than 3, but less than 11. The third side must be no longer than 3 inches and shorter than 11 inches. Okay. So a friend tells you that she drew a triangle with a perimeter of 16 and one side of a length of 8. How do you know she made an error in her drawing? Well, if one side length is 8 and the perimeter is 16, then the sum of the lengths of the two sides remaining must be 8. So underline the correct words of the statement. By the triangle inequality theorem, the sum of the lengths of the two sides of a triangle must be greater than the length of the third side. So by the triangle inequality theorem, the sum of the lengths of the two unknown sides must be greater than the length 8. But 8 is not greater than 8, so there must be an error in the drawing. And that's the end of this section.